Today's lesson will be proportions in triangles. Our objective will be to use the side splitter theorem and the triangle angle bisector theorem. Our essential understanding is when two or more parallel lines intersect other lines, proportional segments are formed. And the second essential understanding is that bisector of an angle of a triangle divides the opposite side into two segments with lengths proportional to the sides of the triangle that form the angle. So the first essential understanding is going to deal with the side splitter theorem. The second essential understanding will deal with triangle angle bisector theorem. So you have the side splitter theorem. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So if you have a triangle, and we do, with QXY, it's saying that if you have parallel lines, or you have a line that's parallel to a side, let's be more precise. So if you have a line that's parallel to a side of a triangle, you're going to have a proportion created from the intersection. So here's the example. I have these two red lines, RS and XY. They're parallel because of the arrows. Therefore, I know that XR over RQ is going to have the same ratio as YS SQ. So to put it more concrete, if I put 1 here, 2 here, 3 and 4, knowing that I have a line RS that's parallel to a side of a triangle, I know I'm going to have some proportions that will be equal. So I know that 1 over 2, so 1 over 2 is going to equal 3 over 4. Or I know that 1 over 3 will be the same as 2 over 4. That's the side splitter theorem. And again, you have to have a line that's parallel to a side in a triangle. And this is for triangles only. It doesn't work for quadrilaterals or pentagons, octagons, so forth. This is only for a triangle. So again, one more time. Side splitter theorem, you have a line or segment that's parallel to a side of a triangle. Then you're going to have proportional sides. So let's do an example. So what's the value of x in the diagram at the right? So first of all, I know that k to l is parallel to p to n. So since k to l is parallel to pn, I now know, okay, that k to m over k to p is going to be the same as ml over NL. So I know that the ratios are going to be the same. So I know that k to m is 12, so 12 over x plus 1 equals 9 over x. Solve by cross multiplying. So I have 12x equals 9x plus 1. So I have 12x equals 9x plus 9. Distribute. I can subtract 9x from both sides. So when I solve for x, I have 3x equals 9, therefore x is equal to 3. Since x is equal to 3, I can substitute it back in. So I know that ln is equal to 3. And I know that k to p is equal to 3 plus 1, which is 4. And again, side splitter theorem. For triangles only, you have a segment that's parallel to a side. Therefore, you're going to have proportional sides. Or I should say proportional segments. Let's do another one. What's the value of the variable? Well, it's a triangle. Therefore, I know I have a side splitter rule because of AB is parallel to CD. So I now know that since AB is parallel to CD, I now have segments that are proportional. So I now know that AE over AC is going to be the same as BE over BD. So A to E is A to C is A plus 4, B to E is 12, B to D is 18. So when I cross multiply, I have 12 times A plus 4 equals 18A. Distribute, I have 12A plus 48 equals 18A minus 12A from both sides. So I have 48 equals 6A divided by 6, and I get A is equal to 8. So again, it only works with triangles when you have a segment that's parallel to a side. I forgot to put A equals 8. There you go. Then I can also find my side lengths. So therefore, A to E is equal to 8. A to C is 8 plus 4, which is 12. You also have the corollary to the side splitter theorem. If 3 parallel lines intersect 2 transversals, then the segments intercepted on the transversals are proportional. So if I have 3 or more parallel lines going through 2 transversals, I know that I will have some transversals that will be proportional. So if I have Q, R, S, T, I know that Q over R is going to be the same as S over T. So 3 or more parallel lines crossing 2 transversals. So let's apply this to this campsite. I have 3 or more parallel lines. I have intersecting more than, I have them intersecting at 2 transversals, therefore I have segments that are proportional. So I'm going to label this X. So I'm going to have A, B, C, D, E, F, G, H. So my proportions, okay, I know that A to B over HG is going to be the same as B to C over GF, and I know that C to D will have over FE. So setting up my proportion, now I can fill in the information. X over 9 is the same as 8 over 7.2, which equals 6.4 over, and I'll call this Y. So to solve this, I picked the ratio with no variables and set it equal to the ratio with one variable. And I can cross multiply, so I have 7.2x equals 72 divided by 7.2 divided by 7.2. So 72 over 7.2 gives us 10. So x is equal to 10. And to solve for y, so I know if I'm going to solve for y, I have again the ratio that has no variables, 8 over 7.2, set it equals to the y, the ratio with y in it, so 6.4 over y. So I have 8y equals 6.4 times 7.2, which is 46.08 divided by 8. And I get y is equal to 5.76. I already solved for C in this case. It's on the previous slide. So let's go with triangle angle bisector theorem. This states if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So if you have an angle bisector indicated by the angle arcs, then I know that you have this proportion. You're going to have x, y, z, q. I know that x over y will be proportional to z over q. Why? Because of the angle bisector. I'm not saying the angle bisector is perpendicular. It's not a median. It's not an altitude. It's just an angle bisector. And it only works with triangles. Therefore, you have proportional sides created. So let's apply it. So what's the value of x in the diagram at the right? Well, I notice that I have angle bisectors. Therefore, I have proportional sides created. So I know that r to p over rq is proportional to p to s, q to s. Okay, why? Because I have angle bisectors. So r to p, I have 12 over 10, and then I have x over 18. So I have 10x equals 12 times 18, 216, divided by 10, x is equal to 21.6. What's the value of y in the diagram at the right? Well, I have an angle bisector. Therefore, I have proportional sides created. So I know that I'll label this. Let's go to my eraser. So here's A, B, C, D. Angle bisector, proportional sides created. So I know that A over B and B over C is going to be proportional to A over D and C over D. So I have y over 9.6 is equal to 24 over 16. Cross multiply, I have 16y equals 24 times 9.4. I have 225.6 divided by 16. Therefore, y is equal to 14.1. And again, it only works with a triangle. With an angle bisector, you have proportional sides created. So let's try this. Use the figure to complete each proportion. So if I have A over B, that means it's going to be D over E. If I have E comparing to F, that means B gets compared to C. So number 2, that's C. And for number 3, you're using a proportional. If I have, let's see, A being compared to BC addition, that means D is getting compared to the EF addition. So what's the value of x in each figure? Well, if the whole thing is 45 here, I know I'm going to find this missing A to B side. A to B is 15, because 15 plus 30 is 45. So I have x over 10 equals 15 over 30. 30x equals 150. So divide by 30. There, x equals 5. Again, this was side splitter rule. This was side splitter theorem, I should say. Here is triangle angle bisector theorem. So I know that x over 12 is proportional to 20 over 16. Cross multiply, I have 16x equals 20 times 12, 240. Divided by 16, I get 15. Classmate says that you can use the side splitter theorem to find both x and y in the classmate's diagram. Explain what's wrong with your classmate's statement. Well, you can solve for y, because y is going to be solved by using the proportion of 2 over 3 equals y over 2.4. And that's how you solve for y. You can't use side splitter to solve for x. To solve for x, you're going to have to use similar triangles. So to solve for x, you can't. You got to use similar. So side splitter for y, and you have to use similar triangles to solve for x. So here's how you solve for x. Okay, I know that I'm going to have A, B, C, D, E. Okay, I know that this angle D and B are the same, and I know that angle C and angle E are the same because parallel lines, transversals, I have corresponding angles congruent. Therefore, I know the top triangle and the big triangle are similar by angle. So I know that triangle ABC is similar to triangle ADE. Okay. Now I can redraw my triangles. So I have A, B, C. I have 2, Y, X. And then I have my big triangle with A, D, E. So A to D is 5, 7, and this is 2.4 plus Y. So to solve for X, I have 2 over 5 equals X over 7. And that's how you solve for X, using similar triangles, not side splitter rule. And that concludes the lesson on side splitter rule and triangle angle bisector. If you have any questions, please see me in class or send me an email and do the homework.